Okay, here we go. All right, so today we're starting, we're going to skip around in Mod 5 in science. This morning I was saying that Mod 5 and Mod 7 are both about energy. I'm going to talk about some kinds of energy today, but I'm not going to have you do the whole of Mod 5. We just don't have time to do all of Mod 5 and all of Mod 7. So we're going to skip around a little bit. So today we're starting Mod 5, science. Eli, are you dancing around because you already did it? So I'm going to share my screen and we're going to take a look at it. So this is Science Mod 5, Lesson 5.02. And today you don't have to submit anything, but tomorrow you're supposed to submit the end of unit quiz, I think. So here we go. Let's take a look at it. And we're going to go through these kind of quickly. I think a lot of it you guys kind of know, and also we just don't have time to do every single thing. So oh gosh, I clicked share to breakout rooms and I don't want to do that, but that's kind of cool. Someday I'm gonna have to try that. All right, so light and heat energy is today. And
I just read the first words, the first paragraph, and then I malfunctioned.
Okay, you malfunctioned.
Yeah.
Light and heat energy. So look at, do you see that picture? It looks a lot like what's behind me today. And those are the northern lights. There are some places in the world that do not see the sun for long periods of time. In Barrow, Alaska, for example, the sun can be gone for 65 days straight where it's night all the time. And then they have the opposite happen where it's day all the time, like all night long. My husband lived up in Alaska and he got to see that. I've never seen it in my life, but it's pretty cool.
So there's something I want to know.
Yeah.
If it's day, if it's always sunny, how would you know when to go to sleep?
Yeah, exactly. So people have a hard time with that, Liam. That's actually a huge problem. That, and then people don't want to wake up when it's just dark all the time. So it's pretty crazy. But you know how the earth is shaped round, right? So at certain times of the year, when the sun is here, the earth is going around the sun, but it's going like this. And so the sun just stays on it all the time. And this side of the earth is just dark all the time. So it has to do with the angle of the sun. My cat has just crawled into my desk drawer. Can you see her? She's being a pain. All right. Consider what life would be like with no light from the sun for such a long time. The sun is a source of both heat and light energy. In places like Barrow, the temperature gets quite cold and stays that way for a long time. Those that live there need to find other sources of light and heat energy. What will I learn in this lesson? I'll learn to investigate and describe light and heat energy, carry out scientific investigations, and identify a control group and explain why it's important. There's 10 pages to this lesson. Sources of light energy. Take a look at these images below. What do they all have in common? Anybody? What do you see in those pictures? You don't have to take turns. You can just talk.
They're all light sources.
They're all light sources. Okay, so here's the sun. Are stars, do stars make light?
Yeah.
Yeah, and a flashlight and a light bulb. Let's see what it says here. The sun and stars light up the earth while light bulbs and flashlights help light up dark spaces that are hidden from the sun and stars. Look again at the 4 images. Which ones are the same type of light source? The sun is a star that is close to Earth. And in fact, it's a very small star. It's kind of crazy, huh? But the reason it looks so big to us is because it's so close to us. So both the sun and other stars are the same type of light source. A flashlight uses a light bulb to shine light in one direction. So both the flashlight and the light bulb are the same kind of light source. Can you think of some more sources of light energy? Can anybody think of a different kind of light energy? I can think of one that we're going to use for our in-person in a couple of weeks, and that's glow sticks. Glow sticks don't have electrical light. They have chemical light energy, don't they? Just like phosphorescence, like a glowworm. Properties of light. Light is a form of energy that spreads out from its source in straight lines until it bounces off a surface or is redirected as it travels through an object. When light energy strikes an object, it cannot pass through. Some of the energy is absorbed by the object and turned into heat. So if you think about, like, in the summer, think about the road and how hot it gets. That's because it's absorbed energy. Other of the energy will bounce off. Have you ever seen, in the summer, have you ever seen waves that look like water on top of the road? That's the light energy bouncing off. The rest, let's see, the rest is reflected away. If this reflected light reaches your eyes, you're able to see something. Every object and substance respond to light energy differently. Some will allow the light to pass through, while others will tend to reflect or absorb the light. In this activity, you're going to investigate how light energy affects 3 different substances. So mix the flashlight with one of the objects to see how light interacts. So if we do flashlight and cardboard, what happens? Does it actually show us? Flashlight, cardboard.
You have to drag it. You have to drag
I have to drag it onto the cardboard?
No, you have to go. So
I have to drag the cardboard onto it? Oh, I have to drag it up here?
Yeah.
Okay. Object. There we go. What's it do?
Then go click submit. And then it gives you.
Doesn't do much. Okay. Cardboard is opaque, which means you can't see through it. All of the light energy that hits the surface of the cardboard is either absorbed and converted to heat, or it's reflected away. Okay. But when you have a flashlight with, do you have to take this away? Colored glass. How do you get rid of it?
You have to click reset.
Oh, this is kind of annoying. I think I'm going to keep going. You guys can play with that on your own later. Did you know light is really, really fast? Who knew that? Did anybody know that?
I knew that.
Yeah?
Yeah.
So the speed of light is like the fastest speed there is. Light travels at an incredibly fast speed. It travels at a speed of approximately 186,000 miles per second. That means it can circle the globe almost 24 times in 1 second. Wow. At that speed, it takes light from the sun about 8.5 minutes to reach Earth. Scientists say that absolutely nothing can travel faster than light. And they think if something could travel faster than light, it would be time travel. Isn't that a little crazy?
That would make sense.
Mm-hmm. Who is making that poppy noise?
Sorry, that was.
Reflection, refraction. This is kind of a tricky term, refraction and absorption. When light energy strikes an object, it can do 3 different things. It can be reflected like a mirror or like off of the hood of a car. It can be refracted. I don't know if you've ever looked at, take a spoon and stick it in a glass of water. Have you ever done that? And
and also that's how rainbows are made.
Yeah, and it looks like the spoon bends. You're right. A prism refracts or separates the light. Nice. It actually bends light.
Yeah. And
when
then
all of the colors in the light are absorbed, you see black. When all of the colors of the light are reflected, you see white. So black and white are not really colors. They're the absence of color. The color of an object is the color that reflects back for you to see. The other colors are absorbed by the object as heat energy. And did you know we don't all see colors the same? Like people, for some people, blue looks like green and all sorts of interesting things like that.
Yeah, I always found it weird. I actually learned that from a book called Real.
It's actually true that boys are more likely to be what they call colorblind than girls. And sometimes boys don't see everything in color.
What?
Wow, huh? Not everybody, but it often runs in families. How light interacts with objects tells us a lot about how light energy can be used to create other types of energy, like electrical or mechanical. How is light interacting with the objects in these images? How is the light energy being used through the interaction? So do you see what the boy is doing right here? What's he trying to do with that magnifying glass? Do you know? Have you ever heard what you can do with a magnifying glass in the sun? You know, Eli?
Fire.
You can cause fire, huh?
Yeah.
Fire.
Hey, are you playing a game with somebody else right now? You're like cracking up. Let's see here. He is refracting or bending the light all together to one spot, and that can convert it to heat and it can start a fire. My brothers were kind of mean and they used to do this to ants. They used to try to fry ants using a magnifying glass.
That is actually a common way to kill ants.
It is a common way. Have you ever killed an ant that way?
I know a lot of people try and have like a magnifying glass and they try and kill an ant.
What is the second picture of right here? What are these things? Anybody know?
Sun.
Solar
panels.
panels. Does anybody have solar panels on their house or apartment?
I see there are some solar panels on one of my neighbor's
Oh,
house.
White House. Yeah, so solar panels work by absorbing the sunlight and turning it into energy.
Yeah.
Very cool. And finally, when we wear sunglasses, we're trying to reflect away some of the sun's light. So that reduces the amount of light that gets into your eyes. Safety alert, don't look at light sources. Light can contain a lot of energy. That energy can be harmful to your eyes. You should never stare at a light source of any kind for too long, and especially the sun. You should never look directly at the sun. When we had the, do you guys remember the eclipse a few years back when the sun was eclipsed by the,
Yeah, I know this. I know that.
by the
One,
yeah.
yeah, that was bad. I was like,
Solar.
I was 4 or 5, and my uncle told me not to look at anything, and we were going to catch air, so it was so scary.
It was got kind of red outside, didn't it? It was very weird. Light can be a very powerful source of energy. Let's see if you can shed some light on this next activity. Use the drawing tools to show how light travels from this light source. Use arrows to show its direction. Include at least 4 arrows. Okay, so I don't know exactly what you're trying to show here, to tell you the truth.
So you just have to draw how light is.
So like it's going in all sorts of different directions. Is that all you're drawing?
Yeah.
Like that? It's going that way and it's going this way.
Yeah, that's really much what
Well,
you're
that
doing.
is not very technical, is it? And it's going this way and it's going the other way. It's coming at us.
It goes pretty much in every direction.
Yeah, that's weird. Okay, select here for the answer. Oh, geez. Oh, I guess I was supposed to go on to the next ones. Oh, well.
It doesn't really work.
It doesn't really work. Yeah, the next isn't working, I guess, because I didn't submit. Okay, bring in the heat. The largest cup of hot chocolate ever made, I love these Guinness Book of World Records, was in Tampa, Florida in 2013 as part of the Festival of Chocolate. It contained 880 gallons of hot chocolate. Wonder what they did with it when they were done. The milk in the hot chocolate has a lot of heat energy.
Stomach ache.
When it's heated, the milk absorbs heat energy from the stove and becomes hot. That's why it's called hot chocolate. If it didn't have heat energy, it would just be chocolate milk. Take a look at these images. What do they have in common? What do you think, guys?
They all heat sources.
Heat sources. Each picture shows the example of heat energy. It is important to know that some examples, such as wood stoves, are sources of both heat and light. Things that give off light often also give off heat. There are some objects, such as clothes irons, that produce heat without producing light, and some objects, like LED light bulbs, that produce light without producing heat, right? Practice like a scientist. The elements in the toaster give energy to the bread. The heat from the fire in the stove heats the air and other objects in the room. The stove energy heats the soup in the pot, and the iron gives energy. Print the Getting Into Hot Water activity sheet and follow instructions to see some examples of what water does with heat energy. And actually, getting into hot water is one of the ones that I think we're going to do together with a microwave. Is this the one? Yeah, where we test the temperature. So we'll be doing this one together. You can do it on your own if you want, but you don't have to, because we're going to be doing it together next week. All right. And that reminds me that I think I forgot to record this whole thing. Heat energy always moves from warmer objects to colder ones. So if you add ice to your drink, some of the heat energy from the warmer drink moves to the ice. The drink cools down because of the heat energy has been used to melt the ice. Let's look at some more examples. Ice cream melts on a warm day because heat energy moves from the warm air to the cool ice cream. The air has lost heat and ice cream has gained it. Water freezes on a cold day because heat energy moves from the warm water to the colder water. The water has lost heat energy and the air has gained it. That person is going to get that ice cream all over their hand. Heat energy can be moved from one place to another. You can take your hot hand and put it on your face. You can rub your hands together and you get warm hands. Here are 3 examples of mechanical energy being converted to heat energy through friction. So one is pushing this, one is sharpening a pencil, and that's friction, and one is rubbing your hands together. light and heat energy practice. In this lesson, we have seen many objects that transform light energy and objects that transform heat energy. We've even seen objects that transform both. Now it's time to see if you can explain heat and light energy, how they're being transferred and transformed in these examples. Don't sweat, you've got this. So now I'm going to let you guys, if you want to, go work with each other on finishing this lesson. You don't have to take the quiz today. You can take it, we're on page 8. You can take it tomorrow. Here's a summary. And then finally on page 10, what's my assignment? Take the 502 light and heat energy quiz. You can do it. So you're going to do that tomorrow. Yes, Nora.
So are we gonna work on something right now in partners?
You can, yeah, you can go to a breakout room and you can finish this lesson. So we're on page 8. You just have 2 more pages. And if you want to, you can also do the quiz with a partner. Okay. It's not due till tomorrow, but you can do it if you want to. Okay, so I'm gonna let you guys choose your breakout rooms. If anybody wants,
I already did it.
if anybody wants a partner, let me know. I'm gonna open the rooms. If you don't want to do this and you just want to chat with somebody right now, that's also okay. At 2:30, we've got the untitled book group. So Amadi, Kainoa, Liam, Jackson, Lauren, we're gonna go to room 1. At 2:30, if you want to go there now, you can go there now.
Honestly, this science was the easiest one out of all of them.
Excellent.
Because
Good, yes.
this thing has been on repeat for the last from the last.
Can we do math in here?
You can. I've got, let's see who I've got. Amadi, Kainoa, Liam, Jackson, Lauren in room 1 in a minute. So, Liam, why don't you head to room 1 and you can chat with Amadi. And
Okay.
then Lauren, I don't see, so I'm going to send him a note. And Kainoa is gone today. I don't know where he is.